This video is on order of operations, PEMDAS versus SADMEP. I'm going to go on to SADMEP, which is used when we are solving equations. So SADMEP uses the exact same diagram as we did with PEMDAS. It's just we're going to use them backwards because instead of simplifying an expression, we're going to be solving for a variable. So again, we have S and A, which is addition and subtraction, just whichever one comes first in the problem. Then we have multiplication and division. Then we get rid of the exponents. Then we undo parentheses. So an equation is two expressions set equal, which the symbol is the two horizontal bars, equal to each other. Now remember that an expression can be a number, a variable, and operations. So it could be 5, it could be 5x, it could be 5x plus 2. It's anything that has something in it, a number, a letter, operations in it. Solving an equation means getting an unknown variable alone in an equation, which another word for that is when we are isolating. We're going to isolate a variable. And again, a variable is a letter. So you might have heard solve for x. This means that we want to get x completely alone on one side of the equation and everything else on the other side of the equation. And we're going to use that by undoing PEMDAS. To undo PEMDAS, we use SADMEP because we're going to go backwards. So if we have two-step equations, first we're going to get rid of either subtraction or addition. Now, to get rid of subtraction, we're going to get rid of subtraction by adding to both sides. Because what you want to do is keep it like a seesaw. We want to keep it even. If we have 5 on this side over here, we want to make sure we can get 5 on this side to keep them even. So if I have 5 here and I need to take it away, I need to take away 5 from the other side as well to keep them nice and level. Otherwise, you change the value. Understanding that solving or rewriting something means that the value will stay the same. It's just the way it looks will change. So if we have addition on one side, we're going to get rid of that by subtracting from both sides. And this is both sides of the equal sign. So again, we're going to have two expressions equal to each other. So one expression is going to be on the left, one expression is going to be on the right. After we've gotten addition and subtraction on the other side, then we're going to go through multiplication and division. So then we're going to get rid of either multiplication or division. We'll get rid of multiplication by dividing, because that is the inverse of multiplication, dividing everything on both sides. There is a difference between when we add and subtract and when we multiply and divide on both sides. Adding and subtracting, numbers can go with numbers and letters can go with letters. If I have an x and I have a 5, those cannot add and subtract together. If I have an x and an x, I can add those together and I can subtract those. But multiplication and division, anything can go. So if I have a 5, I can divide by an x because it's multiplication and division. So the inverse of division would be multiplication. So in order to get rid of division, we would division by multiplying. Again, everything on both sides. So an example of solving equations says to solve 3x minus 7 equals negative 9. Now, there is one letter in this problem. That is why it's an equation. This is an expression, 3x minus 7. Negative 9 is an expression because it is a number. And we have one on the left, one on the right, and we have an equal sign. This is why it's called an equation. So solving this equation means we're getting the unknown variable alone. That is the x. We have one letter x and we want to get that alone. So what I'm actually going to do first, I'm going to make a little note over here because this is something that can help us. We're going to circle the letter or the variable that we're solving for. The reason we do this is so that we know that this is what we're solving for. But the other thing is you don't want to move it. You don't want to move it. If you only have one letter in the problem, you want to keep that letter where it is. So anything attached to it needs to be moved away from it, but that letter itself, just the letter, needs to stay where it is. If I had a letter on the other side, I would need to get all of the letters on one side before I can finish. So I'm going to circle this letter X. I'm going to start solving. So first, we're going to get rid of addition or subtraction. So on here, there's nothing that can combine. I can't simplify this together to make it smaller. This is as small as it will go. So I want to get rid of subtraction by adding to both sides because I have a minus 7. The 3 is attached to the x, directly attached to it. It is a coefficient. It is multiplied to the x. So I can't do multiplication until I get rid of the subtraction. So SAD. So I want to get rid of the subtraction by adding 7 to both sides. So I'm going to add 7 to both sides. The reason we do this, negative 7 plus 7 gives us 0. So that 3x was never touched, and we still have that equal sign. I'm going to draw a line because I want to keep that equal sign where it is as well. I just drew a dotted line. That negative 7 plus 7 is 0, so I no longer have to have anything on this side with the 3x. I come over here, negative 9 plus 7 is negative 2. I have no more addition or subtraction on the left-hand side of my equals. I have a 3 times x. So now I can go to get rid of multiplication or division. This is 3 times x, so I'm going to get rid of multiplication by dividing everything on both sides. So I'm going to circle that x again because I still need to get that alone. I'm going to divide, so the division symbol, everything, so everything on both sides, by that number of 3. Because that's what's attached to the x that I need to get alone. So 3 divided by 3 is actually 1. Still never touched that letter x, and I still have my equal sign. Now, negative 2 divided by 3 is negative 2 divided by 3. That is a fraction. We're going to keep that as a simplified fraction. Now, we have 1x equals negative 2 over 3. Well, when we have 1x actually just means x. Because there's only one x, so I could actually just write x there. So I could say x equals negative 2/3. And that is our solution. We finally have x alone. The x is completely by itself. And I have everything else simplified on the other side. So x equals negative 2/3. I'm going to highlight that as my final solution. And that is solving equations using SADMEP.